Hi everybody, this is Mr. Parr, and this is just a quick lesson on how to find the equation of a circle about the origin. Now, before we can get started, first thing you need to make sure you've got a good understanding of is circles and its parts, coordinates, and Pythagoras' theorem. Without those, you may find this a bit tricky to do. So, let's go into this. Now, here you can see I've got a set of axes with a red circle being our circular graph. Now, this circular graph we can now break down. So let's do that. If I mark on here, obviously you get that the origin here is coordinates 0, 0. If I was to mark a point over here, hopefully, even without knowing anything about this circle, you can recognise that the distance from here, even if I said this was 6, this point here, that would mean our coordinates would be 6, 0. But that doesn't change the fact that the distance from here at the centre to here at the circumference is our radius. Meaning that we have a radius that equals 6. Now, even without the number, I can completely ignore this, and this is where I'm going to look at this as an expression. I'm going to ignore numbers and just look at the principle behind this and get you to understand where it comes from. So if you can understand that, finding the equation of a problem and solving other problems around this can be really, really simple. So, let's do that. I'm going to take a circle here. And what we're going to do is we're going to move the radius. Rather than have the radius coming out along the axes, we're going to have it come from the centre and out to the circumference this way. Pardon the fact that's not a straight line, but you get the point that this is a radius. Now, any diagonal line can then have drawn off of it two perpendicular lines to make a right angled triangle. Now, the brilliance of doing this, for those who can't see it, making a right angled triangle, it means I can form lengths. Now this length will be some length along the x, and this vertical length will be some length of y, because this point here has coordinates x and y. I'll show you what I mean with that again, very quick, with numbers for that, if just in case you're getting a bit confused. If I did this with numbers, and I had a radius coming out, irregardless of what it is, let's say this hits at the points 3, 4, I know if I was to draw a vertical line and a horizontal line out, that this point here is 3 out and 4 up. So that's why we can call these x and y, because whatever these coordinates here are, I know that this width is that coordinate, and this height will be that coordinate because we started from the origin. The centre of the circle is the origin. So that coordinate there gives me these two lengths. And that's what's great about this. And this is why we can do it. No matter what they give you, you can find the equation. But the reason why this is great, and we know this is always true, because no matter where I draw r out, that r value is not going to change. It's always going to be r. Yes, I'll get different sets of numbers for my x and my y. You know, this y and this x will be different to this x and this y. But when I use them in Pythagoras' theorem, I will always get the same answer out for this radius. Because if you consider it, what we've actually created is a right angled triangle whereby the hypotenuse is always r, the width is always x, and the height is always the y coordinate of this point. So therefore, anywhere on here would be the same. I should get the same answer out. Or I will get, not I should, I will in fact get the same answer out. So now if I take this and use Pythagoras' theorem of a squared plus b squared equals c squared, and I put it in alphabetical order of x squared plus y squared, because they're the two shorter lengths, equals the hypotenuse squared, which in this case is r. There we are. We have an expression for always finding the equation of a graph. We know the coordinates will always be x and y of wherever it is out here, and x will always be the distance out, y will always be the distance up or maybe down if you're getting a position, let's say over here in a negative quadrant of the graph, but it will always work, and I'll prove it to you. If we go to, and I'll show you, and I'll also show you how we use it to get an equation. So here we are. Here's a circle, generic size, and I'm going to say that this point here has the coordinates of 4, 0. Okay, so we got 4, 0. And I'm going to use that expression of x squared plus y squared equals r squared. Now if we look at this, we can see that the radius out is 4, because going from the origin out to here is just a change of 4 in one direction. So that must be our radius. So I can just say therefore that x squared plus y squared equals 4 squared. So therefore x squared plus y squared equals 16. And there we have it. I have the equation of my circle graph. Done. Let's try another one. Because what if I didn't give you that point? What if I gave you another random point? Let's say, or not a random point, let's say I gave you a point on the y-axis and said that this had coordinates of 0, 7. Well, that doesn't matter either. Again, I can employ this, and we can equally see that that is still the radius from this point vertically up to that point, because any line out in any straight line out, in any direction from the center is the radius. So from 0 y value up to 7 y value means it must have a radius of 7. So I'll do x squared plus y squared equals 7 squared. So therefore x squared plus y squared equals 49. Done. I have my equation. Simple as that. I mean, if I wanted to, let's look at it another way. What if I then gave you just a random point? I didn't give you the top. I didn't give you the side. What if I just went out to a random point? What if I just gave you a circular graph, again like this, and you were told that that coordinate there was 6, 8. Well, we know this is a circular graph. We would have been told that. They'll have to tell us that. And that this is the origin. And so there's my radius. I'm just going to use Pythagoras again. Or I'll just use this again. We know that that is a point on this graph. So it has to be true. So if I just use my x squared plus y squared equals r squared again, I'll just substitute in the 6 and the 8. You could have done that with the 4 and the 0. If you did 4 squared plus 0 squared, you'll get 16 from this one up here, and using those. So it follows that if I use 6 squared plus 8 squared, I'll get the r squared. So I'm just going to quickly go to my calculator here and do 6 squared plus 8 squared equals, and we get 100. There we are. And I've got my r squared. I don't even need to square root it, because we know x squared plus y squared equals r squared. So my equation is x squared plus y squared equals 100. And I've got the equation of my graph. Done. As easy as that. And you could have done that with this. You could have done 4 squared plus 0 squared gets 16, as I said before. Now, next slide. 3 questions for you to have a go at, because I know often when we do these things, we like to see that we've understood it by testing ourselves. So here's 3 very quick questions. Have a go. Obviously pause the video and then press play when you're ready to do the answers. Okay, so I'm assuming by now obviously you've pressed play, and here come the answers. Now, first one, again, x squared plus y squared equals, this has got a radius of 5, so that's quick. We can just put 25 here because we know 5 squared is 25. Done. Next one, x squared plus y squared will equal, radius is 8, so 64. And this one, top to bottom, is our radius here this time. That's going to be 10 because it's straight up, so that's a straight line radius. So x squared plus y squared equals 100. And again, on each of these, I could have done the same. I could have just taken the coordinates of that point on the circumference and done it this way. So take this one, I could have done 5 squared plus 0 squared, and you would have got 25 still. So again, the equation is x squared plus y squared must always be 25. Do the same here. 8 squared plus 0 squared is 64. 0 squared plus 10 squared is 100. It works. You could even test it over here, because if that's 0, 10, then that over here has got to be 10, 0. 10 squared plus 0 squared is 100. It works. I hope you found this video interesting. If you did, I hate to say this, but please give it a like, and I'll try and get more videos made. Again, this has been Mr. Barr. Thank you for watching.